adding to what we already know, let's take a look at something called multiplicity. Multiplicity is a very, very easy concept because basically what we're looking at is we're looking at the factor, whatever the factor happens to be, and we want to know how many times it repeats itself. That's what multiplicity means, multiple repeats. Okay, so how many times a factor repeats itself in a function? Well, what do I mean by that? Well, let me show you something really cool here. You know and I know when I put an x squared into a graph just like this, and I hit a graph, I'm going to get this, right? But I want to show you something really cool. Do you realize that it doesn't matter what the power is? I can actually put a power of 4 here as long as I keep it even. That's the important part. I'm going to keep them all even. Watch this. If I graph it, I basically get another parabola. Granted, this parabola has a little bit more of a flatter bottom to it like this, but so what? Watch this. I'm going to show you again. Watch this. This is so cool. I'm going to change this to 6. So guess what? I'm going to graph it. Look at that. I get basically the same thing with the flat bottom on the parabola again. And I keep going in terms of 8, 10, 12. As long as the degree is even, that's the cool part. So look at this. If I have an even number here for multiplicity, so in other words, this factor is repeated an even number of times. Let's say x minus a squared, or x minus a to the 4th, or x minus a to the 10th. Those are all even numbers. I'm always going to get bada boom right there, right on the x axis. And we have a specific name for that. When it's just touching the axis, we call it tangent. So just touching the axis means it doesn't go over, it goes up to the x-axis, touches it, and away it goes down. So predicting, look at this. We can actually predict what this particular graph, its factored form and its roots are going to be, which are going to be very, very cool. Watch this. I can say, well, wait a second. That looks like maybe a -3. That looks like, oh, probably about a +3. So check this out. We know that x equals to -3, but has a multiplicity of, well, that being a bend, it's got to be an even. So I'm just going to say it has a multiplicity of 2. Okay? Watch this. This is the other root, but it just goes through. It doesn't do anything fancy here. So guess what? We're going to say that this has a multiplicity of only 1. Aha. So what does this mean? This basically means that this shows up twice. You got -3, -3, and this guy over here being +3. So you have x plus 3 once, x plus 3 twice, and x minus 3 is your other factor. So guess what? Dun, 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 dun. You can write this as x plus 3 squared, and x minus 3 is your other factor. There it is, multiplicity of 2. Oh, that's awesome. That is so cool. Look at this. Let's do the same thing, but odd multiplicity. So I'm going to go from the simplest multiplicity of x cubed. Let's see what it is when I get a degree of 3. Graph it. Well, you know what it looks like. It's got that kind of S shape to it, right? Cool. Does this work with everything? Well, let's check it out. Give me another odd multiplicity. Let's try 5. Okay, x to the 5. Let's graph that. Looks kind of the same, but look, again, it's getting a little bit flatter here, right? Okay, let's go to another multiplicity. Check this out. Let's go to a multiplicity that's got a degree of 7. Another odd degree. Graph it. Oh my gotcha, it looks the same. It still gives you that kind of S shape to things. So going back to the notes here, what can I say about an odd multiplicity? An odd multiplicity, there's the S shape. It doesn't matter if the S shape is this direction or this direction. It's based on a lot of other things. For example, look at that. What is your end tendency? Even on this question, what is your end tendency? Aha! Okay, so it has a few more things that we have to talk about and we'll blend in, but the cool thing is there's that factor. So we can actually figure out this one. Let's say that this one here looks like it's at about -4. Let's say this one is at 1. This one has to, because of the bend in the graph, has to have an odd number multiplicity. Oh, I don't know. Let's just say it's 3. It could be 5, it could be 7, it could be 9, it could be 11, could be whatever. But we know that this, in fact, is going to have an odd multiplicity out there. So this is going to have a factor of x plus 4 to a multiplicity of, let's say, 3. And this one, since it's just straight on through, only has a multiplicity of 1, and that's going to be x minus 1. That is your polynomial. That's going to look an awful lot like that. Okay, if you don't believe me, guess what? I can throw this into my calculator and I'll actually show it to you. So just popping that in there, there's x plus 4 cubed. So we know that we're going to have some sort of factor at x equals to minus 4, and it's going to be 3, and we have another intercept here at x equals to 1 here. Okay, perfect. So let's graph it. Let's see if I get the prediction that I had earlier. Watch. Boom. Graph. Sure enough, there it is. Look. 1, 2, 3, 4. Right there. There's the root. Look at that. That's at 1. There's that S bend that I talked to you about. There is your odd multiplicity right there, folks. Boy, that's cool. Wow. Okay, so with that in mind, let's just keep on going. Let's go to this one now. So if we got an even multiplicity, we've got that parabola shape, right? If we got an odd multiplicity, we of course have that S shape that looks like that. Now the parabola could be either opening up or like that or opening down. This S shape could be either direction, okay? But what if you have no multiplicity at all? Well, we've been doing ones like that. No multiplicity at all. Looks like it just cuts through the x-axis just at a beautiful spot. There's no tangential line, okay? There's no tangent like over here. And there's no intersect that looks like an S curve to it at all, okay? So, cool. Let's put this into play right away. All right, now let's think. Look at this example. Could you imagine if we had to use the remainder theorem, the factor theorem, and integral theorem? Oh my goodness, you're going to be here for a month of Sundays. This is just ridiculous. So let's start looking at it. I factored it for you. Okay, and the cool thing you look for is number 1, look for this. That's a degree of 6. That's a positive leading coefficient. So it means that this is going to be going up in that direction. And you better have 6, count them, 6 factors. Well, there's 3, 4, 5, and 1 more is 6 factors. A lot of them just happen to repeat themselves. Look at this. This guy, no repeat. So at minus 3, 1, 2, 3, there's a factor, no repeat. This one's at minus 1, okay? There's a factor, but look at that. It's got a multiplicity of 2, so you know that this guy's going to either be upwards facing or downwards facing. We haven't predicted that yet. We haven't figured that out why. Okay, so let's keep on going. And this guy's got to be at plus 2. 1, 2, and look at that. It has a multiplicity of 3, so that's going to have some sort of bendy shape to it like that. Okay, look for that. Now, here's what's interesting. Leading coefficient is going this way. Now, also, this is an even degree, which means guess what? That's going to conclude out that way. Also, look at a couple more things that we have to look at. Oh my gotcha. Check this out. You got a minus 24 here. So way down here is going to be minus 24 at your intercept. Aha, so we've got a lot of interesting things happening. Okay, let's look at this thing. Okay, x plus 3. So I know it's got an tendency of both of them going up because it's an even degree. So I think this guy's going to come down this direction somewhere like this. Okay, then this has got a squared on it. So I think it's going to have that nice little parabola shape for it. But since I'm down here, what's going to happen is this guy's going to have to bend back up like this, and then I'm going to have my parabola. There's my tangential parabola. Remember, it just touches the x. So there's my parabola kind of shape, meaning that this guy's got to come down this way now. It's got to hit this guy over here, and then up here, here comes my multiplicity of 3. So I know I'm going to have some kind of S shape here, and then finally conclude by going that way. That's my prediction of what this graph looks like. Well, guess what? I've got it on my calculator already. There it is. Oh my gotcha, that's huge. Okay, I'm going to graph it. I was right. Oh my. Yes, it comes down this way here, goes out here, outside. There's my multiplicity of 2, comes back. There's my intersect. There's my S curve, and I'm out. Both of them pointing upwards. Woo, baby, look at that. So let's throw some conclusions down here. If you look at this, it says, complete the following. All right, let's talk about the zeros. The 0 here is not plus 3. The 0 is minus 3. Remember, it is a minus 0. Multiplicity of only 1. Description, it just cuts right through. Cuts through, no curve. Okay? That's cuts through. Okay. UGH. Oh my goodness, the English teachers around the world right now hate me. Okay, now look at this. There's minus 1. So our 0 is at minus 1. A multiplicity of 2. This is going to be my curve. This is going to be my curve that's parabola shaped or U-shaped. Okay? Now, here we go. Our last one is at plus 2. And that's a multiplicity of 3. And this is going to be my S shape. Beautiful. Look at that, folks. Oh, what we learned so far, this is powerful. Now, next one. Remember, degree of the polynomial also comes into play here. The degree of the polynomial is 6. So including all the multiplicities. Look, this is multiplicity of 3, 4, 5, 6. Look at that. These always have to match. They have to. So using technology, the minimum of this function is, now here's the cool thing. We're looking for the minimum. So if we bring this guy back up, take a look at this. We're looking for this minimum, which is way, way, way down here. We haven't figured it out yet. So we actually have to change our window settings here. And I've got a very strange looking window setting right now. So we want to be able to see the bottom of that. Okay, so let's go to our window setting. Look what I've got it at. I've got it at minus 70 already. Holy smokes, and it still doesn't show the entire graph. So let's play around. Let's go to minus 100 and let's see what it is. Let's see if it draws it. Oh, close. Let's keep on going. Let's go to about minus 120. Let's see. Okay, graph that now. Aha, now we can find this guy. And remember, we're finding a local minimum here. How do we do that? Same way you did this all the way back when you did this in Math 20-1. You hit second calc, find me that minimum, which is 3. Mouse this guy over, okay? So we're mousing it over. There it is. Whoa, too far. Okay, enter, go to the right, enter, guess, and our local minimum is at minus 2.5 at minus 102.5. Holy smokes, lots to learn in this particular podcast. Sorry it's so long, but boy, is it ever powerful.